Figure 20.10 Iterator operations for each type of iterator. In this table, we list out the various types of operations that you can perform on iterators, and we separate them into various categories by the categories of iterators, and in the first two cases here, operations that can be performed on all iterators. So every single type of iterator supports the ability to use pre-increment or post-increment, which simply says move to the next item in the underlying container that the iterator points to. Separately, we have operations for input iterators, which include the plus plus operators, and the ability to dereference an iterator, which gives you access to the current element that the iterator points to. And of course, again, this is an input iterator, so you cannot use it to modify the value that it points to. You can assign input iterators to one another. You can also compare input iterators as well to see if they are equal or not equal to one another. And that's a commonly used technique to help determine, for example, if a repetition statement that's walking its way through a container has reached the end of the container. In particular, we'll do that frequently with the not equals operator. Now, output iterators, in addition to plus plus operators, support dereferencing the pointer so that you can place a value into the item that the iterator points to, and assigning one iterator to another. Forward iterators support everything that you see above this in the table, and that's true, by the way, for each of the subsequent categories as well. Bidirectional iterators, on top of all of these capabilities up here, add the ability to subtract one from the current iterator's location, thus moving to the previous element in the underlying container that the iterator is pointing to. And then finally, we have random access iterators, which, as you can see here, are quite powerful. They have lots of different capabilities, and these capabilities apply specifically to the vector class and also to the deck class and anything else that might somebody might create that supports random access iterators. So it's possible for people to create their own data structures that adhere to these capabilities as well. Now, in the case of a random access iterator, a couple of the things that we can do are to add or subtract an integer to or from a given iterator. So if I add an integer to the iterator and store the result in the iterator, it says move the iterator by that number of positions into the container. If I subtract, then it says move that iterator backwards through the container by that number of positions. I can also add or subtract an integer from an iterator without modifying the original iterator in memory. I can subtract two iterators, which is going to tell me the distance between those two positions in the underlying container. Basically, how many elements are there between these two iterator positions. I can use the subscript operator just like I do on a pointer or array name to say using a given iterator to go that number of positions of offset from the current iterator location into the container and grab an element. So if I say that the iterator p is pointing to the first element in a vector, then when I say p sub 0, that will give me the first element. If I say p sub 9, that'll give me the element number 9, the 10th element in the underlying vector. I can compare two iterators to see if one is less than another, which is only useful in a vector or a deque where the underlying data structure is actually an array-based data structure. So by comparing two iterators that are pointing into the same vector, we can tell which one is closer to the beginning of the vector, and we can do that with less than or equal to, greater than, and greater than or equal to as well.